Hello, hello.
Hello,
Can you
I
hear
can
me?
hear, sir.
Okay. Yeah, I can also hear. So now eighth is finished. So ninth schools are going on or vacations is started.
The vacations. April 6th, 9th will start.
No, can you speak a bit louder, or then we can bring that
April
mic?
6th, 9th, and it will start.
Okay. So it's started. So how long the classes will be there? Like till 1 month.
Yeah, April 6th to April 28th.
Okay. So anything is started in mathematics?
No, the school has not yet started. It will start on
Okay,
April.
yeah, it's okay. Okay, it's not yet started, and it will start from 6th April. Huh?
Yeah.
Okay. So, did you get the books?
Yeah, books I got.
Okay, book you got in mathematics. Like, okay, have you gone through the chapters? What are the chapters there in mathematics?
Yes, sir.
The first one is a number system. I'll just take the book. I'll just check. NCRT book only, na? Any other book that teacher has recommended?
No, sir, only this.
Okay, so till now, nothing is. I'll just take out the book. I'll just check what things are there in that one. I think the first chapter is number system. Yeah, the first one is number system.
Yes.
Hello.
Yes, sir, I can hear.
Yeah, I can hear now. Uh, so, like this number system was there in your previous classes also.
Yes.
Can you tell me what exactly is the meaning of a of this term, number system?
Representing numbers in a number line.
Representing the numbers in a number line. Anything else?
So that's it.
Number system means I think you have done in earlier classes also seventh and eighth. It is nothing but a way of representing the numbers,
Yes.
right? Clear?
Yes, sir.
So the way that we represent the numbers, so that we can use the numbers, we can do the calculations, or we can use those numbers in our daily life according to our requirement. We use the number system, right?
Yes.
Now, in that number system, actually, there are various types of different sets of numbers that we use. I think this also you might have done earlier. What are the different types of numbers that are commonly used?
Whole numbers, natural numbers, and rational numbers.
Okay, so which number system you have studied first?
Uh, Whole numbers and natural numbers.
Whole numbers and the natural numbers. So, uh, okay, first actually it is the natural number and then the whole numbers. Can you tell me what exactly is a set of natural numbers?
Natural number starts from 1 to infinity.
Natural numbers starts from 1 to infinity. Okay. Anything else about natural number that you can tell? Like, okay, you told it starts from 1 and it moves to till infinity. What's the meaning of infinity?
Uh, like uncountable number. It can extend up to any number.
Just अभी शुरू किया 1 घंटा चलेगा 1 घंटा हो जाएगा No, just now you told like the natural numbers. It starts from one, and it till infinity.
Yes.
One, we know. Okay, you know what is one, but what exactly is the meaning of infinity? Infinity. Infinity actually it means a very, 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 very large number.
Okay.
Is it clear?
Yes, sir.
So infinity, so a natural number means it starts from one and then moves on two, then three, then four, then five, then six, and so on. That is one step, and it moves to a very large number which we cannot even count, which we cannot even count. That is called an infinity. Is it clear now?
Yes, sir.
Is it clear?
Yes, sir.
Okay. Now, this is about the natural numbers. Now, the next you told about the whole numbers.
Yes, sir.
Can you be a bit louder or can bring the microphone closer to you?
Okay, sir. Yeah. Hello.
Yeah, now I can hear a bit. What I was asking, what exactly is the meaning of whole numbers, the set of whole numbers?
Whole number starts from 0 and ends up to infinity.
Okay, so whole number you told it starts from zero and it moves till infinity. Clear? Infinity just now I explained. Now, can you tell me what is there any difference between the set of natural numbers and the whole numbers?
Yes, natural numbers, 0 is not included.
Natural numbers.
0 is not included.
Okay, zero is not there. In natural number, it starts from one, and whole numbers, it starts from zero. Now, next thing, can you tell me which set is bigger? The set of natural numbers is bigger or the set of whole numbers?
Uh, the whole numbers.
The set of whole numbers is bigger. Okay. Uh, so if a set of whole numbers is bigger and the set of natural numbers is smaller, uh, it means if we add some numbers in a set of natural numbers, we'll get whole numbers. Is it clear?
Yes.
Hello.
Hello. Yes, I can hear.
Yeah. Yeah. So which number if we add to a set of natural numbers and we get a set of whole numbers?
Mm, the 0.
Zero. Okay. Next is which is the lowest number or the smallest number in the set of natural numbers?
1.
One. And which is the highest number in a set of natural numbers?
So, infinity.
Infinity. What is infinity?
It's a
Is it
very
a
large.
fixed number?
No, it's not. We
It's
can't
a
count.
very large number. So, what we can say about the highest or the largest natural number? Is there any highest natural number? Is there any largest natural number?
No.
Yeah. So, infinity. Since infinity, it's not a definite term. It's not a fixed term. So, we say that there doesn't exist any largest natural number, and the same is the case with the whole numbers, right? Is it clear?
Yes, sir.
Okay, after natural numbers and whole numbers, which set you have done earlier?
Integers.
Integers. Okay, now we'll come to the set of integers. Uh, okay, before moving on to integers, can you just tell me how, which, with which letter we denote the set of natural numbers?
N.
N. Okay, capital N we use to denote the natural numbers. With which letter we denote the set of whole numbers?
W. Capital W.
The, huh?
Capital W.
W. Capital W. Capital W is the letter that we use to denote the whole numbers. Okay, now next moving to the integers. Okay, integers, can you define the set of integers? How will you define the set of integers?
Uh, Integers include both positive and negative numbers.
It consists of
Both positive and negative.
positive and negative numbers. Which numbers?
Natural numbers.
Natural numbers. Okay, all the natural numbers, if we take the positive numbers and negative numbers, is there any other number apart from natural numbers and
Whole
positive and
number is
natural
also
numbers negative?
whole number.
Zero.
Yeah, zero.
Yeah, obviously the natural numbers 1 to infinity, and if we include negative sign, that is minus sign, with the natural numbers minus 1, minus 2, minus 3, along with 0, it is called the set of integers. And can you tell me which is the smallest integer?
Smallest.
The smallest integer. Like in natural numbers, the smallest natural number is 1. In whole numbers, the smallest whole number is 0. Can you tell me which is the smallest integer?
-1.
Sorry, I cannot
Minus
hear.
one.
1?
-1.
Minus 1. Okay, minus 1 is the smallest integer. What about minus 2?
So -2 is larger than -1.
Yeah, minus 1 is larger than minus 2. Then how can minus 1 be the smallest integer?
So your voice is breaking.
The
Can you?
smallest integer. Can you hear me?
So now I can hear.
Okay. So the question, what I was asking is, like in a set of natural numbers, we have 1 is the smallest natural number. In a set of whole numbers, we have 0 as the smallest whole number. Can you tell me what is the, which one is the smallest integer? Can you see the board?
Yes, sir. Uh,
Hello?
so -1.
Minus 1. Okay, I'll just draw the number line over here. The natural numbers you told, okay, it starts from 1, then 2, then 3, and so on up to infinity. Right. This is the smallest, and there is no largest. Clear?
Yes.
Can you see the board?
Yes, sir.
Okay. Now, similarly, in a set of whole numbers, W, it starts from 0, 1, 2, 3, and so on up to infinity. 0 is the smallest, and there is no largest whole number. If I write the set of integers, just now you told the set of integers they represent by Z, and we have all the positive numbers 0, 1, 2, 3, and moving up to infinity. And then before 0, which number will come?
So
Yeah, no, the question is, yeah, to the left. The question is the negative numbers will come on the left of 0. Clear?
yes.
And the positive numbers will come on the right of 0. Minus 1, minus 2, minus 3, and so on up to here minus infinity. Can you see the set of integers represented on the board?
Yes, sir.
Okay. Now, can you tell me which integer is the smallest integer?
So infinity.
Infinity. Which infinity? Two are there. The positive or the negative?
The negative.
Negative. Okay. So it means in case of integers, there is no smallest number.
Yes.
Clear?
Yes.
Because just now you told like infinity is not a fixed number. Which one is the highest number?
-1.
The plus infinity. It's clear?
Yes.
Hello?
Yes, sir, it's clear.
Okay. Now, which one will be the middlemost number in the set of integers?
So 0.
Zero. Zero is the middlemost integer. So in the set of integers, we can say that the set consisting of all natural numbers along with their negative numbers along with zero is a set of integers. And there is no largest number, there is no smallest number, and the number that exists at the middlemost position of the set is the set is a number zero. Is it clear?
Yes, sir.
Okay, what else have you done?
The rational numbers.
Rational numbers. Okay, now moving on to rational numbers. What are rational numbers?
A number which is represented in the form of P by Q.
Okay, the numbers which can be represented in the form P by Q are known as rational numbers. What are P and Q? The numbers represented in the form P by Q are rational numbers. That is clear. But the question is, what is P, what is Q?
The natural numbers.
P and Q are natural numbers, okay? So rational number means it is of the form P by Q, where P is a natural number, Q is a natural number. So if I write 2 by 5, is it a rational number?
Yes.
Okay, because 2 is a natural number, 5 is a natural number, so it's a rational number. What about this number, minus 2 by 5? Is it a rational number?
Yes, sir.
But just now you have told like P and Q should be the natural numbers. Is minus 2 a natural number?
No, sir, it's an integer.
It's an integer. Okay. So can you just redefine a rational number? Because just now you told a rational number is a number which is of the form P by Q, where P and Q are natural numbers. So it means the definition is wrong, because minus 2 by 5 it's a rational number, and minus 2 it's not a natural number, it's an integer. What about 5? Whether 5 is an integer?
Uh, so 5 is a natural number and an integer.
Yeah, so the definition will be a rational number which is represented in the form P by Q, where Q is not equal to 0, and P and Q are integers. P and Q are integers, not the natural numbers. Because if you say natural number, it means then we cannot write the negative numbers. We cannot write minus 2 by 5, we cannot write 2 by minus 5, we cannot write minus 3 by minus 7. Is it clear?
Yes, sir.
Right?
Yes, sir.
So yeah, so that's why whenever we use the term rational number means it is a number which we represent in the form P by Q, where P and Q both are integers, and Q is not equal to 0. Q is not equal to 0, right? So this is the rational number. Now, can you tell me like 2? It's a natural number, right?
Yes.
2 is a natural number.
Yes, sir.
2 is a whole number also. Clear?
Yes, sir.
2 is an integer also.
Yes.
Am I right?
Yes, sir.
Okay. Can you tell me whether 2 is a rational number or not?
Yes, sir.
How can you say that 2 is a rational number?
So 2 can be written as 2 by 1.
2 can be written in the form 2 by 1, right? Where 2 is an integer, 1 is an integer. Okay, so 2 is a rational number. 0, whether it's a rational number or not, 0,
Yes, sir.
0 is a rational number. Okay, 1 over 0, 1 divided by 0. If I write a number 1 over 0, whether it's a rational number or not,
No,
it's not a rational number. Why?
because q is equal to 0, but in a
Q
diagram
is equal
was
to, yeah, Q is equal to 0, because by the definition of a rational number it says that the number should be of the form P by Q, where P and Q both are integers and Q should not be equal to 0. Clear? So this is a rational number. Anything else that you have done earlier in number system?
uh, so that's it.
Okay, that's there. Okay, now we'll see what's there in the book in number system. Okay, about the number line. Okay. Now, what is a number line?
So where a set of integers are represented, both positive and negative.
Okay, it's a horizontal line where which is used to represent the numbers. Okay. Now, there are two terms. One is a line, one is a line. Actually, there are three terms: line, line segment, and array. Can you tell me the difference between a line segment, and array?
um so a line, both the sides can be extended to any point.
Okay, so the line it extends till infinity on left and till infinity on right. Okay, it continues extending. What about the line segment? What is a line segment?
It has two particular endpoints.
Okay, it
Both
has two particular endpoints. One is called the beginning and the other is called the end. Clear. What about the ray? What is a ray?
the ray only one side can be extended. It starts.
Okay, a ray is, yeah, a ray is a type of a line that starts but not ends, but it does not ends. Okay, it starts. So and now, did you understand why it is called a number line and why not a number segment or a number ray?
Yes, sir. Because
Because this line we represent the numbers which moves from minus infinity on the left till plus infinity to the right, that it never ends, right? So that's why we can represent the integers and the numbers or the rational numbers on the number line. Okay, now one next question. Suppose if I write two numbers, 2 and 4.
sir, I can't see the board.
The two numbers are 2 and 4.
Sir,
How
I
many natural? Yeah, can you see it on the board? Two numbers are written 2 and 4.
no, sir. Can you put the device mode down? The board is only till the number line.
Okay. I'll just put it over here. The two numbers are 2 and 4, right?
Okay. Yes.
Now, can you tell me how many natural numbers are there between 2 and 4?
So three, one,
How many? Okay, one natural number. 3 is there between 2
two,
and 4. How many whole numbers are there between 2 and 4?
so one,
One. Which one?
three.
3, because 3 is a natural number, 3 is a whole number. How many integers are there between 2 and 4?
So 1,
1. Which one?
3.
3. Okay. So 3, it's a natural number, 3, it's a whole number, 3 is an integer. Okay. Now coming to the next one, how many rational numbers are there between 2 and 4? How many are there?
So 1,
1. How many rational numbers? Which rational number?
3.
3. 3 is a rational number. Okay. So only one rational number is there between 3 and 4, 2 and 4.
Yes.
So, okay, 3 is there. Now between 2 and 3, there is a number 2.5.
Yes.
2.5 lies between 2 and 3.
Yes.
2.5 lies between 3 and 4. Similarly, we can have 2.1, 2.2, 2.3, 2.01, 2.001. So how many are there?
So between 2 and 3.
Actually, if we take any two rational numbers, or if we take any two integers, or if we take any two natural numbers or whole numbers, however close they are, we can find infinite number of rational numbers between any two numbers. Did you get this one?
Yes, sir.
Because if we take the integers, or natural numbers or the whole numbers, then we can say definitely, okay, between 2 and 4 only 3 is lying. But whenever we are talking about the rational numbers, we can find infinite rational numbers between 2 and 4. Or similarly, if we take 3 and 4, similarly 4 and 5, 6 and 7. Is it clear?
Yes, sir.
Okay, now next thing is about the. Okay, now the next thing is like, I think these type of questions were there in the previous class also, like inserting rational numbers between two given numbers. Have you done such type of problems?
Yes, sir.
Okay, so can you do such type of problems now?
Yes, sir. Sir, but last year I did
Okay,
only
just
fractions.
yeah, last time, last year also we did such questions. Just wait for 2 minutes. I'll bring the duster. Duster. Now here, I have written two numbers. Can you see the two numbers on the board?
Yes, sir.
Yeah, 3 and 5. Can you find any rational numbers between these two rational numbers, 3 and 5?
Mm. Sir, but last year we did only between two fractions, like 2 by.
The same method. The method will remain the same. How will you find a rational number between these two rational numbers? The method will remain the same. What
So
steps we
last time
followed?
uh, I took the LCM method.
Okay, LCM method. No, LCM was to bring the. You remember last time we did like fractions and unlike fractions?
Yes, sir.
What are like fractions?
That have the same denominator.
The fractions having the same denominator are known as like fractions, and the fractions not having the same denominators are known as unlike fractions. And why we take LCM is to make the fractions as the like fractions so that we can get the same denominator. So taking LCM but what steps we used to follow if we want to insert number between two numbers? The first step was to add the numbers, and the second step was to divide the sum by 2. Did you remember?
So this method actually I didn't follow.
Okay, so if we want to insert any number between the two given numbers, so the first step, what we do, we add the two numbers. We add the numbers 3 and 5, 8, and then 8 will divide by 2. Will obviously we can see that 4 lies between 3 and 5. Is it clear? Now, can you use the same method to find a rational number between 4 and 6? What you got?
Sir, I'm doing it. The 5.
So what? Yeah, 5. So what you did first?
I added 4 and 6 and then divided it by 2. The
Okay,
sum,
you added the two. Okay, you added the two numbers 4 and 6, and you got 10, and you divided by 2. You got 5, right?
yes.
Now, suppose if instead of 4 and 6, if I take 4 and 5, can we find any rational number between these two numbers, 4 and 5?
No.
A rational number between 4 and 5? Follow the same procedure
Okay.
just now we did for the previous one.
So 9 by 2.
How much you got?
9 by 2.
9 by 2, right? 9 by 2 or 4.5. We can say that it's a 4.5 also. Similarly, okay, I'll take between 4 and 5. You got here 4 and here you got 5. In between these two, you got 9 by 2. Can you find a number between 4 and 9 by 2? What will be the number between a rational number between 4 and 9 by 2?
So the same method.
Same method. Whenever the question comes, insert a rational number between two rational numbers. We always add the two rational numbers and divide it by 2. How much you are getting 4 plus 9 by 2?
So first when I took 4 plus 9 by 2, I got 17 by 2 when I added those both.
Hmm. So how much you are getting? 4 plus 9 by 2. 4 plus 9 by 2.
17 by 4.
17. Okay, 17 by 4 after dividing.
Yeah.
Okay, 17 by 4. So a rational number between 4 and 9 by 2 is 17 by 4. Similarly, can you find a rational number between 9 by 2 and 5?
19 by 4.
19 by 4. Which two you use 9? Okay, 19 by 4 will get over here. Can you find a rational number between 4 and 17 by 4?
So 33 by 8.
How much you got?
33 by 8.
16 plus 17 is how much? 16 plus 17 is 33 by 8, right? 33 by 8 will lie between 4. Similarly, we can find between 19 by 4 and 5. 19 by 4 and 5. How much it's coming?
So 39 by 8.
Yeah, 4, 5 is 20 and 39 by 8. So like this, you can see we can find infinite number of rational numbers between any two rational numbers. If we take 4 and 5, we can find a rational number between 4 and 5, which is 9 by 2. Again, we can find a rational number between 4 and 9 by 2, which is 17 by 4. Again, we can find a rational number between 9 by 2 and 5, which is 19 by 4. And if we go on continue this procedure, we can find infinite number of rational numbers between any two rational numbers. Is it clear?
Yes, sir.
So I think the first exercise is about that only, to find the rational numbers between. Do you have a book with you just now?
Yes.
Yeah, so you can see in your exercise 1.1, such type of questions are there. Is 0 is a rational number? Can it be written in the form P by Q? And to find 6 rational numbers between 3 and 4, 4 by 5, right? So can you do these questions now?
Yes, sir. So all.
Okay, so no, no, you take this as a homework. I'll just check it tomorrow, right? These questions.
Okay.
So today was just the beginning, just the introduction.
Yes, sir.
We'll continue next class if other things like irrational numbers are there, and many other things will be there. Now, what we can have, like tomorrow also, we can have it on around this 3 o'clock.
Morning. Morning.
Hello.
The mornings are you free?
Okay, morning time you want?
Yeah.
Okay, so tomorrow, like around 11 o'clock,
Okay.
right? So tomorrow it's Thursday. So Thursday and Friday, Saturday also we can have in the
Class.
same time around 11 o'clock. You know? Okay. So tomorrow, just finish this exercise 1.1,
Yes, sir.
right? Only I think 4 5 questions are there. So we'll discuss these questions and then move on to the next one. And one more thing, whatever you have done in your earlier class, just revise those things also. Clear?
Okay.
Because in mathematics, whatever you'll do now in the next class, then means it won't be you'll find it difficult to solve the problems if you forget what you have learned in the earlier classes, right? So in
Yes.
mathematics, it's very important to retain whatever you have learned in your earlier classes. It should not be like, okay, what you have done in sixth, seventh, eighth. If you forget those things, then you'll not be able to do the problems in ninth and tenth. Clear?
Yes.
So free time, just go through those books also, your last year
Yes.
books, right? So tomorrow 11 o'clock, right?